Hello and welcome to the third lecture in the OxRAM Robot Arm software lecture series. Today we're going to start making some ROS nodes in Python. So today we're going to go over how to create and run Python code in Ubuntu. Then we're going to create a couple of ROS nodes with Python. We're going to make a simple publisher-subscriber system from scratch. And then we're going to create our first toy ROS application, a square number factory. Now, a reminder for the GitHub repository where you'll find the lecture slides and the example code. So I really recommend you having this on hand as you follow along. Now, in the last lecture, we went through setting up the workspace and we created a package. So now we're going to start making Python code inside that package that we made. So I'll catch you in Ubuntu. Okay, so here we are in Ubuntu. And what we're going to do is we're going to first need to navigate to that scripts folder. So we'll go cd, we're at home, so we can go tutorial workspace / source / tutorial scripts. Like that. So that's put us here. And now what we're going to do is we're going to make a new folder. So we're going to create a scripts folder. You should hopefully have caught on how to do this at this point. Scripts, there you go. So the scripts is where we're going to keep our Python code. SRC, that tends to be where you keep C++ code or like code that you would have to build. But Python, you don't build Python. You can, but you don't have to build Python code. So we're going to keep it inside a scripts folder. So we're going to go into there. So cd scripts. So here, and we're going to create a file. So we can use the touch command. So touch just creates a text file. Publisher.py. Touch example _ publisher.py. Yeah, there you go. So what we're going to do is we're actually not going to code it through terminal. We're going to code through it here. And again, we're going to want to edit our preferences. Let's see. Editor. Fonts and colors. Here we go. So we're going to want to make this like bigger. There you go. So now we can, hopefully that should be a little bit more visible. Okay. So what we're first going to do is we're going to add the shebang to the top of the page. So user. By the way, for these first two pieces of code that I'm going to write, I'm going to type them and I'm going to go through, you can type along with me if you want. But after these two, I'm just going to go through the code that I've already written with you guys, just to mean that this doesn't take forever. Because my typing is not the fastest, and if I try to make it faster, it evidently messes it up a little bit. So this first line that I've just written, it establishes the file as Python 3 code. So this bit, it's called the shebang. So then what we're going to do is the next line is going to be ROSPy. So this line, it imports ROSPy. So ROSPy is the package that provides all the basic ROS-based Python tools that we need. So it provides all of the Python methods and stuff for ROS. And we're also going to import standard messages. So this will allow us to create message objects and then publish those onto a topic, and also subscribe to that topic to receive the messages. So yeah. So now we're going to define a publisher. So we're going to say pub. So this is going to be an object. pub equals ROS_pi publisher. Oh shoot, publisher like that, and then topic. I'll explain what each of these arguments are in a second. Standard score messages dot message dot string queue size equals 10. There you go. I'm going to make this a little bit bigger. There you go. Okay. By the way, I've commented this code in the GitHub repository and on the lecture slides. I'm not going to waste time doing it here, so you can refer to it if you want to a reminder of what these lines do. So what we've done here is we set up publisher object. So we're calling the publisher method is ROS_pi. So we're the constructor really, and so this first argument is the name of the topic to which our publisher will publish. So we're going to publish to this new topic that we're making called example topic. And now we have to say what kind of message. So for a given topic, you can only ever publish one type of message. So in this case, we're going to be wanting to publish string messages and see how we're initializing a string, but this is from standard messages. That's why we needed to import standard messages so that we could say string here. Because this isn't just your ordinary string. This is a string message, and a ROS message is more. It's a more complicated object than just like int or string or whatever. The ROS messages contain those things, so that's the actual data that you're sending. But all the extra ROS-y stuff is dealt with that you don't need to deal with by sort of just creating the object using one of the ROS message, the pre-existing ROS messages. Now, what queue size does is this says how many messages you can have stored up that you haven't yet published. So if you want to publish, you can later on, we're going to tell the code to publish something, but sometimes it might have to it has to wait in a queue to be published before any further, before you can. So it has, if you want to publish multiple things to the same topic, you have to wait in a queue, and this queue size means the number of things you can have in your queue. So if you have 11 or more, all the further additions to the queue are going to be discarded until there's space on the queue. Hopefully that makes sense. So queue size 10 means that we're probably not going to have any losses of messages that we're trying to put on. So the next thing we do is we're going to say ROS_pi dot init node example underscore publisher. So what this line does, this line turns this Python script into, when we run it, it will turn it into a node. So we're initializing the node, and the name of this node is going to be example publisher. And a really creative naming. And then r equals pi.rate 1. So we're defining the rate at which our publisher will publish messages. So r is the rate object, and it's defined as frequency. So this is 1 hertz. That would be 10 hertz. That would be 100 hertz, etc. So you want typically, the rate at which you're publishing messages is dependent on your application. What you're using it for. But this is going to be 1 hertz. Oh shoot! I should say ROS_pi rate like that. There you go. Yeah, that looks good. Okay. Now we're going to want to create a loop. So because we're going to want it to continuously publish in this case. So we're going to say while not ROS_pi dot is shut down. So what that if you're familiar with while loops, it basically means that the contents is going to be running as long as ROS_pi is not shut down. So when we shut down the ROS node, this should get killed. Pub publish. So we're now we initialize the object up here, well, we instantiated the object up here, and now we're going to call the publish method. So pub.publish standard underscore messages message. I really hope I'm not going to make a typo somewhere here. That would be annoying. But the thing is, you can always debug, so that might actually be a good, good thing to. It won't be the end of the world if I mess it up. Because show what you should do when say things don't go correctly. Pub.publish send a message string example message. Yeah, that looks good. Okay, so this while loop is run continuously, and then we say r.sleep. Okay, so basically, what's going to be happening here is we first import the things that we need, then we instantiate a publisher object, with the topic, with the type of message that the publisher will publish onto the topic, and the queue size. And then we're going to initialize this program as a node, and then we're going to give it a publishing rate of 1. Then we set up a while loop here so that as long as the program's running, we're going to get it to publish the message. I should say here, I should explain how this works. So publish, and so this is an object. So standard messages.message.string, and this is what the message contains. This is the actual data of the message. It's going to the actual string that this string message has is example message. If that makes sense, it'll become more clear once we actually run everything. And then we get it to sleep for a second if we're running it at hertz. So it would be sleep for 1/10 of a second if we made it 10 hertz. But yeah, so I'm going to save that. And you see it's now changed to a Python because of the shebang there. It's got the little Python icon. So now we've made our publisher, and now we're going to need to make our subscriber. So we're going to go back here, and funnily enough, we're going to touch example subscriber. Example subscriber. Yep, that's right. .py. Awesome. Now again, let's go through this again. So what you first need to do is you need to add the shebang. Did I do it properly? Yes. Okay. /user/bin. So you first need to add the shebang to, so that we can say that this file is actually a Python 3 file. And we're going to import ROS.py because we need that, and we're also going to import standard messages. There you go. Import ROS.py. Import standard messages.message. So the way that a subscriber, the way the publisher works should hopefully be quite straightforward. So you just tell it to publish, and it publishes. The way that the way the subscriber works is when a subscriber receives a message, it calls a function to handle the message that you've received. So this is called a callback function. So every time you receive the message, it plays a function that you define, which is what it will do. So we're going to define a function here. So def callback. So we're defining a function. Message. So ROS.py.log info. Message received. Then we're going to say it's a string. And then message.data. .data. There you go. Okay, that looks good. We're done with that. Okay, so we've defined the thing here. So this is the name of the function, This is the input argument, the message. So ROS, what log info does is in terminal, in whichever terminal the node is running from, it will write this line, message received. So it's going to say message received, and then it's going to say what the data stored within the message is. So in this case, it should say example message, because that's the actual string that's stored within the string message that we've made. If that makes sense. So there we go. But now we're actually going to create the main body of the program. So if underscore name equals name, there you go. So now again, ROS.py init node. We're going to initialize the node. Example subscriber. ROS.py dot subscriber example topic. Standard messages dot message dot string callback. So what's that's doing? So okay, let's put that in there as my spin. Okay, so we initialize the node, example subscriber. Then we set up the subscriber, much like we did with the publisher. So ROS.py.subscriber, and we're calling this one. We're saying that it's a subscriber to example topic, and here we're saying that the messages that it's receiving should be the string messages. And when it receives these messages, it should run the callback function that we've defined here. So every time it receives a message, it should then do this. It should run whatever that is. And ROS.py spin, basically, it just stops Python from exiting until you manually kill the node. So this isn't a while loop. This spin just stops the program from terminating. So it'll be constantly waiting. It'll be waiting in anticipation for messages, and every time it gets a message, it will do the callback. So there we go. That's that complete. Now we're going to test our code. Fun. Before you can run your code, you need to give it permissions to be executable though. So we're going to need to first make our code executable. So let's do that. So go to terminal, and what we're going to go is we're going to do sudo chmod a plus x example publisher .py example subscriber. So you need to do this in the same directory as your files, by the way, and you need to do this for every new script that you make. So always remember to do this. So sudo chmod a plus x example publisher.py example subscriber. At the terminal, it froze, so I'll just restart it now. So now I'm going to give permissions. So I need to give my password. There you go. So now we should have permissions to run our scripts. So in general, you should. So remember to do that every time you make a script. So now in 3 separate terminals, we're going to run the following. So okay, so we're going to let's run the ROS core in this one. Oh, that's not right. Oh, come on. There you go, ROS core. And then ROS run tutorial scripts example publisher. Okay. ROS run tutorial scripts example subscriber. There you go. It's working. Not a single error. It's a bit funny. Let's see if I can. There you go. Okay. So you should see something like this. So here you should see the message received. You shouldn't see anything there. And this is just ROS call. So now I'm going to run ROS topic list in this fourth one. You see we've now got example topic. And now we can say ROS topic, echo, X. There you go. So let's have a little talk about what's going on here. So our publisher node, example publisher, is repeatedly publishing the message example. Well, it's publishing messages containing example message onto the topic called example topic. So we can see here, so there's the publishers running, and we're echoing into example topic. So this, we're seeing what example topic sees, and in the data of the messages that receives, we see that it's saying example message, which is what we told the publisher to publish. Meanwhile, if we look at the subscriber, you see every second you can see the log. So it's running ROS. This is what a ROS Pi log info looks like. Every second it receives the message, and then it plays the callback. In our callback, we told it to say message received, example message. Well, message received, and then what the message, what the message that it received says. In this case, it says example message. So that's all working nicely. So in this very simple first example, the publisher node example publisher was repeatedly publishing the message example message onto the topic example topic. And the subscriber node example subscriber listens into that topic, and it receives the messages, printing them in terminal. So that's exactly what we saw. Now we're going to go a little step further, and we're going to consider a toy application, the square number factory. So imagine a system where a customer generates a stream of numbers and requests for a service to square them. These numbers are going to be squared by a separate factory, and then a third member, the receiver, collects the square numbers from the factory and then prints them out. So for the sake of brevity, I've gone ahead and coded up these three new Python scripts in advance, and I've also given them permissions. So let's now go through them one by one. Okay. So the first one is the customer. Here we go. Now this node is just acting like a publisher. So one thing to note here is we're also importing random, because we use this for random number generation. You see, this is going to be the name of the publisher, and we're going to be dealing with integers here. So I've said 16-bit integers, so not strings anymore. So we've changed the name, and we're going to do this every half a second. So we're going to do this at a rate of 2 hertz. So that's the rate at which the customer is going to generate its new random orders. And if you can see here, so this is in a while loop. So, again, while ROS Pi is not shut down, we first generate our order, a random integer between 1 and 10. And then we state what the number to be squared is. So we broadcast it in ROS Pi log info. Well, log info. And then we publish it. And then we sleep for half a second. And then the process continues. So that's how the customer works. Now in the factory, imports are the same. But yeah, and note here that we're setting up a publisher in this one as well. So this is the processed square number. So, okay, I'm going to expand this to make it a little bit more readable. So something very interesting happening here. So I'm going to come back to this in a sec, but first going to look here in the main code. By the way, the point of the main code is that this code only gets executed if this is this particular script that you're executing. Because what you can do is you can import methods and stuff from one Python script into another Python script. So, for example, if we could have another Python script that imports stuff from this one, and it would acquire the callback message, for example. It would acquire the callback function. But what this does is this if name equals main, it prevents this from running if this is not the actual script that we're running, which is, because obviously you don't want this to run if all you want to do is import this function into your other script. Anyway, so we initialize the node and we initialize the subscriber, so the square number order. And so we're going to listen in for orders, and we're going to spin. So this is very similar to the subscriber in the previous thing that we did. This very simple example. But have a look here what we're doing in the callback. So when we receive the message, we say what order we've received. We then square it. So we create the processed order, which is just the message data times itself. And then we're going to say what the processed order is. And then we're going to publish. So in this case, the square number factory node, it publishes its message from inside the callback that its subscriber executes when it receives a message. So whenever the factory receives a message, it actually publishes one in response to a different topic. So this, it listens into, where is it? It listens into square number order, and it publishes onto processed order. So there you go, it publishes. So it will publish every time it receives a message. Okay, that's how that works. Finally, the receiver. This is very simple. This is pretty much just acts as a subscriber. This is basically the same as the simple publisher subscriber example. So now what we're going to do is we are going to run each of these and see what happens. So ROS call. Cool, ROS call's running. I ignore this nonsense. That's just when I stretch the terminals to make it bigger. Sometimes it messes, it garbles itself a little bit. So this doesn't actually have a bunch of S's there. That's just like what the terminal visual is showing. So yeah. ROS run. Tutorial scripts. Square number customer. There you go. So here we see, here we go. At a rate of 2 hertz, we're getting random numbers to be squared. In this one, ROS run. Tutorial scripts. Square number factory. There you go. So now compare the two. Every time the every time the customer publishes an order, the factory receives the order and then sends out the processed order. So you can see it's always the square, as it should be. And then finally, square number receiver. There you go. And now compare these two. Every time there's a processed order, it shows up here as a received square number. There you go. Now, note that our new program uses 3 nodes and 2 topics. You may be wondering, it would make a lot more sense to just have the customer and receiver be the same node, right? I mean, the customer is the one making the orders after all, so surely they'd be the one that wants to receive the the squared numbers. And it's just It just seems much more efficient doing 2 nodes. Now, there's a technical reason for why we weren't able to do this. As great as simple publisher subscriber systems are, they do have their limits. And if we wanted to repeatedly publish messages with a time delay, as we were doing with the customer, that means that we can't continually be listening for new messages at the same time. It's just not how the while loop works, I'm afraid. Now, if you're an experienced ROS user, you may know a way to actually only use 2 nodes here without using ROS services and actions. If you think you know the solution, just message me. But I'll be impressed if you can figure it out. But it's beyond the scope of this course. Now, a better solution would be to use ROS services, which would be an ideal solution here. ROS services allow you to set up a client and a server. Now, the client sends out requests, which a server uses to complete the task. So once it's done, the server sends the output back to the client. So this way, the customer will also be the receiver of the output once the task is complete. So we only need 2 nodes, and it's a much more direct 2-way system of communication. So we'll cover this in the next lecture. Now, and one last thing before we move on and do more coding in further lectures, I really recommend getting to grips with a code editor, which will make your life much easier when you're doing coding. Because the standard text editor, it was sufficient for the simple programs. So we're going to really want to improve our code editor situation going forwards. So I recommend VS Code because it provides real-time error checking, and it even suggests quick fixes. It provides debugging. It has an integrated terminal. It provides easy file and folder management, and so much more. So this is taken from VS Code here. So you can see file management. We've got the code editor here with all of the different parts of the code colored in different colors. And if you hover your mouse over it, it'll actually give you information about all of the different things. And also here's an integrated terminal. And there's lots of different extensions in Visual Studio Code as well. So there's an extension for Python and Pylons. There's VS Code icons will make the icons for your different files more clear. So that will help with your file management. There's a ROS VS Code extension, which means that all the ROS specific code will have documentation for them if you hover over the code. There's great extensions for C++ as well as Python if you're familiar with C++. Okay, let's quickly go through the installation of VS Code just to finish off for today. So I'm going to go ahead and open up terminal here. So I'm on this. I don't actually know if I linked this in the lecture slides, but if you just look up Visual Studio Code on Linux or use this link here. There, and just follow these instructions. But we're gonna skip this top one. We're gonna do these here. So what we're gonna do is we're first going to run this line. So sudo append GUI. Okay, great. It's already there. Then we're going to get the Microsoft packages. Okay. Then run this. You're just running a set of running a set of commands really. And this one, and then finally that. Okay, and now we move on to here. Hopefully that all works fine. Yep. Okay, then sudo update. This should be quite a familiar command at this point. You should be doing it, every time before you start trying to install new stuff. There you go. Now finally, the actual installation. Sudo apt install code. So this will actually install VS Code. Yeah. Shouldn't take too long. Hopefully, it's already about halfway done. And after this, so once this is installed, I will kind of go through setting it up for use. For development. I'll do a very simple setup. You can embellish with all sorts of bells and whistles, but I just thought I'd get you started just to help out some beginners. There you go. So that's installed now. So now, if we go here, we should. There we go. Put it there. We've got Visual Studio Code. Look that up. Okay. Let's make it bigger. Okay. Just go next section. Next section. Okay, let's just close the welcome thing. It might actually be worth going through that if you want, just to familiarize yourself. But so yeah, we're going to open up here. We're going to choose tutorial workspace, and that's going to be our project filter. So here we go. So you can see here we've got source. Yes, I trust the folders. Yeah, I trust the authors in here. Okay, so you can see we've actually got it shows the file system within tutorial workspace. So we've got source, and then the only folder inside source currently is tutorial scripts. Then we go into scripts, and look, and here's all of our code. And you can adjust the font size and stuff. Oh yes, we're obviously missing some extensions, so let's download some extensions. So Python is is quite an important one. Python, installing Pylance. As well. Oh, that's installing with Python. Okay. And then we're going to install the ROS one as well. And it'll become apparent what these extensions will do. Yes, code. Icons. Yeah, there you go. No. Jeez. It's okay. We can VS Code PDF is also useful if you want to print out your, if you want to export your code as PDF. But not necessary. Just a misclick. How's the installations going? Okay. I think they should. Okay, it's VS Code icons. You can actually see the icons have changed a little bit because of that extension. So if we load up, if we open up a script here, you can see it's nice and colorful like before, but there's a lot of other functionality. So for example, what we can do is we can have a new terminal. So we can run stuff from the terminal at the bottom here, rather than rather from this terminal. So that's there. You can see we're in the tutorial workspace. And here we go. Look, now everything's pretty colors. So if you click Publisher, the reason it's all gone all green is because we've got our extension set up. So if you hover over it, you can see it's recognized the ROS Pi module. And look, if we hover over subscriber, it sorry, if we hover over the publisher method, it tells us all the information about all the inputs, etc. And if you say something wrong, so if you say publish, and I'm going to just add an M there, publish, it's not going to recognize it there. So it's quite easy to, much better. Yeah. And if you can run code and can debug and all that stuff. So there you go. That's a very quick, a simple intro to VS Code. So in today's lecture, we covered creating and running Python code in Ubuntu. We created our first couple ROS nodes with Python, the simple publisher subscriber system, and we tested it. And then we moved on to the square number factory, so our first toy ROS application, and we looked at how that works. And we also discussed how it could be done better with a little bit more advanced ROS functionality, which we'll be looking into next time. So for your homework, go over all the code we went through today, make sure you understand what's going on, and also set up VS Code or whatever code editor you want to use, and make sure that's all ready to go. So next time we will learn about ROS services. So that's the end of the third lecture. Thank you for watching. I hope you enjoyed it, and I will see you on the next one. Goodbye.